Welcome back, guys. Today I'm gonna start working on a new sensor, that is TMP101NA, that's a temperature sensor. Regarding the recent videos we have showed, we have been working on different digital temperature sensors. So let's add a new one to that series. And to know more about this sensor, let's have a look over the website, that is controleverything.com, and here search on for this sensor, that is TMP101NA. Now we see that it's a digital temperature sensor with alert function, and it's a I2C temperature sensor, 9 to 12 with user selectable resolution, and as you can see the accuracy is there. So some of its features you note it down. Now you can purchase this sensor from here also. I will be interfacing the sensor, digital temperature sensor TMP101NA with a Raspberry Pi, and a Python code is required for that. So I will just go to resource tab, and here comes my Python code sample. Now what we're gonna do is to download the code as zip file from this very link. Also, you can have the code from GitHub repository, and it's called Control Everything Community. Now let me show you the hardware connections we're gonna make to set up a proper environment regarding the interfacing of this sensor along with the Python code. This here is our sensor, that is temperature sensor TMP101NA, and these are the GPIO pins of a Raspberry Pi, and as you can see it's a Raspberry Pi. Now what we require is to make a connection among the Raspberry Pi and the GPIO pins and with the sensor. So what do we need is an I2C shield, which you are able to see on my screen, and it's available on the website controleverything.com. Now gently place over the I2C shield over the GPIO pins of the Raspberry Pi, which comes into the picture right now, and we want to make a connection with the sensor also. So we need a connecting cable. Now make this connection among the sensor and the cable, and while making this connection, make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly we have to follow this set of rule for the I2C shield. Now we need to power up our Raspberry Pi, and we need a micro USB cable just like this, and gently put it over the power jack. Finally, we need an internet connection so that we can set up our Raspberry Pi along with the sensor. So there are two ways. First of all, an Ethernet cable can be connected at the Ethernet jack, and you can insert it up there. Now if you have an wireless adapter, nano adapter, you can also use that. It might save your day also. So finally we are done with the connections part. What do we require is to a code so that we can interface it with our sensor. Let's have a look over that also. Now for the interfacing purpose we require a Python code. So the first step is to log in and search here in the website, that is github.com, and here we have to search for the repository, that is Control Everything Community. Now this is the required sensor we are talking about, and this is the Python code we will like to explore. But let's have a look over the instructions we need to follow to pursue this code. It says that we have to download and install SMBus library on the Raspberry Pi, and the steps are being provided on this very link for the installation purpose. Let's have a look over the website or the link, and we can familiarize with it for the installation. Now as you can see, all the relevant information is provided here. Note it down and get it done. Now this is the command to run the Python code. Now here's our Python code, and it's a .py extension file. Now coming to the code, first of all we have imported SMBus and time libraries, and after that we have the address of the sensor, that is 0x49. Now writing section, we have selected configuration based to having address 0x01, and 0x60 goes for continuous conversion, comparator mode, polarity, active low, 12-bit resolution command, and the writing command is here. After that we want to read some data back from the sensor, and we are reading data back from 0x00. 2 bytes of data are read, as you can see, temperature data. Now we want to convert the data right to 12 bits, as you can see, and use some formulas which are being provided in the datasheet for TMP101NA. After all, we want to have the data to be displayed on the screen, the results, and that's temperature and Fahrenheit for you, C and F scales, and we have perfectly formatted into 2 places of floating point value. Now let's have a look over again, and it's a very simple and generalized code as far as concerned. Now what we know about the working, and to get it done, let's have a look over that also. Now comes the interesting section, that is to show the working, the practicality of this Python code. And for that, copy this entire code and open up the terminal regarding the Raspberry Pi via internet, and here create a new file. As you can see, it's .py extension, and here we go, paste the code and save it. Now this is the command to run the code, and now we are done with the temperature in Celsius and Fahrenheit. Now this is how, there's a very minute or no change, but when I exhale, there's a change in temperature. As I exhale, the temperature is changing constantly regarding the change in atmosphere. So this is how a Python code works along with the Raspberry Pi and the sensor TMP101. Now what we're going to do in the next section is to provide the details regarding the application and the features of this sensor. Let's have a look over there also. The TMP101NA device is a digital temperature sensor ideal for negative temperature coefficient and positive temperature coefficient thermistor replacement. The device offers a typical accuracy of ±1 degree Celsius without requiring calibration or external component signal conditioning. The TMP101 device features SMBus Two-Wire and I2C interface compatibility. The device allows up to 8 devices on one bus. The TMP101 device offers an SMBus alert function with up to 3 devices per bus. Now, this device is ideal for a lot of applications like power supply temperature monitoring, computer peripheral thermal protection, cell phones, battery management, thermostat controls, environmental monitoring and HVAC, and a lot more. This sensor is available and can be purchased from the website controleverything.com, and you can get the code from resource tab. After that, you can download it from there also. Also, you can get the code from GitHub repository, that is Control Everything Community. In the end, I would just like to make it clear that at any point, if you are not able to understand any part regarding any section of this video, you can have your further queries on controleverything.com, and you can post your comments on the community page. For blogs, articles which are relevant to this video, you can have a look over instructables.com and search us for them. Also, to subscribe more video tutorials which are just like this, you can go to our YouTube channel. Now, in the end, I hope you enjoyed this video and have a good one of yourself. Thanks a lot for watching.